All right, so we are into the probability unit. All right, so this is probability with and or. So if you have a standard deck of cards, what is the probability of? And when you see probability, a lot of times you have P with like parentheses, and what's inside the parentheses is what you're trying to find the probability of. So as you saw in that last video, right, the bottom of the fraction is going to be the total number of outcomes, no matter what the circumstance. And the top is the specific thing you want to happen. So a couple things to know. What does a deck of cards look like? I don't know about you guys, but we've been playing a lot of cards over here. So hopefully you have an idea of what a deck of cards looks like. It's 52 cards, right? So there's 4 suits. There's 13 cards in each suit. And I will post a picture for you to look at of what the deck of cards consists of. All right, so the probability of a heart. So that's a suit. So there's 13 hearts out of a whole deck is 52. Okay, jokers are not included in a deck of cards. Probability that it's not a queen. Okay, so, well, we know that there are 4 queens, so that means that there's 48 cards that are not queens. So 48 out of 52. Now, you could also have figured that out by saying, well, a queen is 4 out of 52. And if I take 1, which is the 1 whole, and I subtract what I don't want, I will get that, right? Because 1 is really 52 over 52. And if I subtract the 4 over 52, I get 48 over 52. Okay, and I can reduce these, obviously. A lot of the times in probability, though, they'll leave it like this because it kind of shows exactly what those numbers are representing. So, you know, any of these formats is fine. And then a picture card. So the picture card includes like the Jack, Queen, King. So we have Jack, Queen, King for each suit, and there's 4 suits, so we have 12 out of 52. Okay, so now we're going to talk about the probability of and the probability of or. So and, we have this symbol for it. So this is the probability of A and B. Now A just means like event A. What's the event? Event could be that it's a heart. Event A could be that it's a jack, right? So it's just whatever the circumstance is. And then event B is something else. So what's the probability of both of these things happening? So, and it has to be both. It has to occur in both scenarios. So you must satisfy 2 conditions when finding the probability. You must find what is common to both conditions. So what is the probability of rolling a number? So this should have been more specific, rolling a number on like a 6-sided die. So just like a regular die. Rolling a number which is even and less than 3. So think about on a 6-sided die, right? So I'm just going to draw a sample set. Oops, I skipped 4. 4, 5, 6. So a sample set just shows what all the possible outcomes are. These are all the possible outcomes. So the bottom of my fraction is going to be 6, right? Because there's 6 possible outcomes. So we want to know how many of these are both even and also less than 3, right? So even could be 2, 4, 6. So there's 3 possible numbers that are even. But out of those, which is also less than 3? So there's only 1 that's also less than 3. So we don't put 2 there. We put how many there are. And there's only 1 number that's possible there. So there's a 1 out of 6 chance of that happening that satisfies both conditions. Okay, so when you have and, usually the probability is smaller. All right, what is the probability of rolling a number that is odd and a 4? Well, the odd numbers on a die, 1, 2, 3, 4, 5, 6, are 1, 3, and 5, right? Out of those odd numbers, how many are the number 4? Well, it's not. That can't happen, right? So if that can't happen, then the probability is 0 out of 6, which is just a 0. It will never happen because an odd number cannot be 4, and a 4 cannot be odd. So it's not going to happen. And then for example 3, what is the probability of choosing a card? So if we're talking about a deck of cards that is red and a queen. Okay, so if you take a look at the picture that I posted, and I'll try to insert here, that is red and a queen. Okay, so out of the red, well, that's half the deck. That's 26 cards, right? So there's 26 red cards. Out of those 26 red cards, how many are a queen? So there's the queen of diamonds and there's the queen of hearts. The other 2 queens are the black ones. So we don't want that because it has to be red and a queen. So there's only 2 cards out of the whole deck that are going to be, can you see that? That are going to be both red and a queen. Okay, so when it's and, it has to satisfy both conditions. When it's or, that's a little different. So that's what we're going to look at next. Okay, so or is this symbol. And this symbol is the kind of opposite than the and, right? So it's like a U. So or, an element can be counted in one set or the other set, but it cannot be counted in both sets. Remember to subtract out the elements that were common in both sets. So sometimes, like, something might satisfy event A and it also might satisfy event B, but we don't want to count it 2 times. Sometimes something will happen in event A and it has nothing to do with event B, and then we don't have to worry about any overlap. So you'll see that here in a couple of examples. So there is a formula. I wouldn't get too hung up on trying to memorize this formula because it's kind of like logical when you go through these examples. So the probability of A or B is the probability of A happening, which is the first condition, like probability of getting a red card or something, plus the probability of B, so whatever the second condition is, that let's say it has to be a queen. And then you have to subtract, well, is there a possibility that it could be both red and queen, for example? We have to take that away. We don't want to count that twice. Okay, so that's what this part is saying. If it's not possible for these 2 to happen at the same time, then there's no need to subtract it out. So it depends on the example. So for or, it says if you're rolling a fair 6-sided die, what is the probability of rolling an even number or a number less than 5? Okay, so it could be either one. So now there's going to be more possible outcomes. It's not as strict as the and was. So I'm just going to write my sample set out again just to look at it. So an even number could be 2, oops, I forgot the 6, 2, 4, 6, or a number less than 5. So it could be any of these, or it could be anything less than 5, which is this, and this, right? So I circled 2 and 4 twice, but I don't want to count them twice, right? It's the same number. So I want to count anything that I circled at least once. So 1, 2, 3, 4, 5. So there's 5 possible outcomes out of 6 that satisfy this. Now let's see how this relates to the equation. So the equation is saying, take the probability of the first thing happening. All right, so the probability that it getting an even number, there's 3 even numbers out of 6. Then the probability of getting the second thing happening, so a number less than 5, so there was 4 numbers less than 5. So if I add those together, I get 7 out of 6. But we learned that you can't have a probability of something happening bigger than 1, right? You can't have a more than 100% chance that it's going to happen. So the reason why it's over 1 is because we counted something twice. So we have to do this part. We have to subtract anything that is both even and less than 5. And that was the 2 ones that we circled twice. Number 2 and number 4 are both even and less than 5. So we don't want to count those 2 times, so we're going to subtract how many of those there were. There was 2 numbers like that, so 2 out of 6. And then these are all common denominators. Keep the bottom. 3 plus 4 minus 2 is 5. Right? So sometimes you don't need that formula because you can just kind of draw it out. and figure it out that way. Sometimes it's helpful to use the formula in certain questions where they kind of give you the probabilities already. All right, so example 2 says, using the spinner, what is the probability of spinning a prime number or an even number? Okay, so here we have to remember what a prime number is. Okay, so looking at our spinner. So we have our spinner here, which I'm going to put a disclaimer here that all of these should be the same size. I know the 2 and the 5 look like they're bigger pieces. Let's just say that they're even pieces. Okay, so if they were not even pieces on purpose, then obviously the probability of landing on each number is going to be a little different, and that's just a little more complicated than we want to get into right now. So let's just say, for argument's sake, that those slices are all evenly spaced. Okay, so the prime numbers. So remember, prime numbers are numbers that have factors that are itself and 1. But remember, 1 is not a prime number, and 2 is the only even prime number. Okay, so those are 2 things that you definitely want to make sure you know. We see that come up on the SAT a lot and the ACT, just like knowing that fact. So prime number, so that would be 2, 3, 5, right? So there's 3 of them. Or it could be an even number. Well, 2 is an even number, 4 is an even number, and 6 is an even number. So when I do or, I just want to see how many things are circled at least once. So there's 5 things circled at least once. So my answer is just 5 out of 6. Now again, if I'm using the formula, the probability of a prime number. So I circled 2, 3, and 5. So there's 3 of them. And then an even number was 2, 4, and 6. There's also 3 of them, right? So if I just added those probabilities together, I get 6 out of 6, which is 1, which is a 100% chance of that happening. But we know that's not true because 1 is not prime or even. So why is the answer 5 out of 6? Well, because one of the numbers I circled twice because it's both prime and even. So I counted it 2 times. So that's, again, why we have that part of the formula, because we want to take away anything I counted 2 times. So that's going to be 1 out of 6, right? Because it's the number 2, but how many of the numbers am I talking about? 1 of them. So 3 plus 3 minus 1, because they all have the same denominator, right? And then I get 5 out of 6. So again, you don't always have to use the formula, but it's good to see how it works. All right, then we have a standard deck of cards. What is the probability of choosing a king or an ace? Okay, so in each deck of cards, there's 4 of each kind. So there's 4 kings and there's 4 aces, right? So if I look at, I'm not going to draw them all out, but if I look at that picture of that deck of cards, I want to just ask myself, is there any card that would be both a king or an ace? Is there any overlap like there were in the other 2 examples? No, a card can't be a king and an ace at the same time. So for this, I have 4 kings out of the 52, and I have 4 aces out of the 52. But are there anything that's both? No. So when I have no overlap, I don't really have to worry about subtracting anything out. So you don't really have to write this part, but just know, okay, there's nothing that's going to be in both categories. So that's 8 out of 52. Okay? If it said and, what's the probability of choosing one card that is both a king and an ace? That would be a 0 probability, right? Because that would be impossible. Okay. All right, then example 4, the probability that Gary and Jane have a child with blue eyes is 0.25. And the probability that they have a child with blonde hair is 0.5. The probability that they have a child with both blue eyes and blonde hair is 0.125. What is the probability they have a child with blue eyes or blonde hair? So for these types of questions, I like to convert everything into the notations with A and B or whatever letters you like. Okay, so here we're talking about blue eyes and blonde hair. So like using the letter B might be confusing. So maybe using 2 letters. So like the probability that they have a child with blue eyes is 0.25. So I'm going to write probability and I'm going to write BE for blue eyes equals 0.25. And then the probability they have a child with blonde hair is 0.05. So I'm going to write probability of blonde hair is 0.5. The probability that they have a child with both blue eyes and blonde hair. So the probability of blue eyes, and I'm going to use a symbol, and blonde hair is 0.125. What is the probability they have a child with blue eyes or blonde hair? So I'm looking for probability of blue eyes or blonde hair. Well, luckily, there's a formula, right? We just learned it up here. So I'm going to use that formula to help me figure this out. Okay, so it's the probability of the first thing, blue eyes, plus the probability of the second thing, blonde hair, minus the probability that they both happen, and then I'm just going to plug it in. So the probability of blue eyes is 0.25, plus the probability of blonde hair is 0.5, and then take away the probability of 0.125. Okay? So plug that into your calculator. Okay. And we plug that in and we get 0.625. Okay, so sometimes that formula is super helpful. All right. Last example I want to do. All right, so this says a high school population has a population of 1,376 students. The number of students who participate in drama is 649. The number of students who participate in athletics is 433. If the probability that a student participates in either drama or athletics is 974 out of 1376, what is the probability that a student participates in both? Okay, so whenever you see a question where they're giving you the probability of one single event, and then they're talking about and or both, that formula could be helpful. Okay, so let's see. I'm going to write it in my notation like I did before. So the probability that they're in drama. So remember, probability, that P, is standing for that probability, that fraction, right? So I know 649 students, but what is that fraction? Out of how many? So it's out of the total. So whenever you have P of something, it should always equal a fraction or a decimal. So that is going to be 649 out of 1376. And the probability of a student being in athletics is 433 out of 1376. And then the probability that they're in drama or athletics is 974 out of 1376. And we want the probability that they are in drama and athletics, right? So if we go back to that formula, the formula is that the probability, so this is what we're looking for, the probability of or is equal to the probability of one thing plus the probability of another thing minus the probability of them both happening. Right? So this is what I'm looking for. So this whole thing is my x. So I'm just going to call it x, so I don't have to write this whole thing. So I'm just going to call that x, and I'm going to plug in what I have. Or is this fraction, 974. All right, my daughter is screaming on Facebook Messenger right now, so If you hear screaming, that is her. The probability of drama is 649 over 1376. The probability of athletics is 433 over 1376. And then minus x. That's what I need to find. Okay, so this is where you're going to need to be really careful in the calculator, because remember, you want to solve for x. So if you add these together and then subtract it to the other side, you're going to get a negative, but that's equal to negative x, right? So you just divide by that negative and you get your positive answer. Okay, so I'll show you how to type that into the calculator properly so we can get our answer. All right, so we're going to use the fancy fraction and add those first two fractions together. So 649 over 1376 plus 433 over 1376. Answer. And then we're going to take that and subtract it from the other side. So fancy fraction again. And I get 974 over 1376. And I'm going to subtract that answer. So I'm just going to highlight it and copy and paste it. And I get the negative, but we know that it equals negative x. So I'm just dividing by -1, which is just going to give me the positive answer, right? So 27 out of 344. Now, a couple things. The calculator obviously reduces your fraction. You could put it in without the fraction since they all have the same denominator anyway, and then get your answer out of 1376, which will then help you find out how many students. So make sure you're paying attention to the question. Is it what is the probability that a student participates in both, or how many students? So if it was probability, which is what they asked me, this is fine. If it said how many students, then I would want it to be out of 1376, because then the numerator is telling me how many students out of 1376 there are. If I had this as my answer and I needed to know how many students that was, I could multiply by 1376, and that tells me that there's 108 students. Okay, so you have to read what the question is asking you, how many or probability.